All right, this is part 2 of the introduction to proofs. We left off in the last little mini lecture talking about the hypothetical syllogism. Uh, the form of the hypothetical syllogism is here. And an example of a hypothetical syllogism would be this. Notice that the P's and the Q's and the R's, right, these are just, when we're talking about the form, those are just placeholders. We could substitute in a sentence, including a complex sentence, that stands for those P's and Q's. So here in my example, this argument is a hypothetical syllogism. It doesn't look like this a lot, but you have to look a little closer. So notice we've got a conditional here. The consequent of this conditional, in this case, is not D. And look at what the antecedent of this next conditional is. See, notice it's the same thing, and that's what's important, right? So this is our P term. This is our Q term. Here's our Q term again, and here is our R term. And if I have that and I understand the form of hypothetical syllogism, then I know I can assert as my conclusion what follows as a valid inference from these two lines is this third line, right? What you need to be able to see is how this argument here, this inference here, is really just an instance of this form right here, and likewise for all of these. So I'm going to go on to some other rules. There are 8 total again. Here are another few rules. Let's start with simplification. The rule, this rule is named simplification. Here's the form of the rule. It says if you have a line of your proof that asserts a conjunction, P and Q, then you are allowed to derive from that line either one of the conjuncts. So I could derive from the statement P and Q. I could derive simply P, or I could derive simply Q. I don't have Q written here, but that would be the same. That also follows. In English, all we're saying is that if I'm asserting a conjunction of two sentences, then it follows that either one of those sentences alone is true, right? So if I'm saying the sky is blue and the grass is green, then it follows, if I'm asserting that is true, then it follows that simply that the sky is blue. And it also follows simply that the grass is green. And again, here's an example of simplification. If I assert A and not B, then I can simplify to simply A, or I could have simplified to simply not B. Conjunction. Conjunction kind of goes the other way around. Conjunction says that if I have a statement P and if I have a statement Q on two separate lines of my proof, then I can infer on some other line, some next line of my proof, I can infer the conjunction P and Q, right? So if you tell me that, the grass is green on the one hand, and then you tell me on the other hand, the sky is blue, then I can assert that the grass is green and the sky is blue, right? And here's just another example applying this form of conjunction to an actual argument. The last one I'll talk about here is addition. Addition is a little weird, but what addition tells us is that if I have some statement, any statement, P again is a placeholder. It could stand for a simple or complex statement. But if I have some statement, P, then I can say, well, either P is true or some other statement, Q, is true. I can disjoin, in other words, to P any statement I want. I can just make it up. Essentially I pull Q out of thin air. So here's an example. Suppose in my proof I have been given as a premise or have derived the statement A. If I have that, I'm allowed to assert, well, either A is true or some other statement, in this case, not B or C, is true, right? The not B or C here is analogous to Q.